Okay, so now we're going to actually be able to test this skyscraper we have, okay, and then change some of the parameters and see how it affects the results, okay. So before going to this, remember yield strength and ultimate strength. Ultimate strength is where it breaks. Yield strength is where, I hope this is in the video. Yield strength is where ultimate strength is where it breaks, and yield strength is where it gets permanently deformed. So we want to stay under yield strength, preferably. Okay, in this scenario, obviously, if you're designing, there's lots of other things that go into it, and you'll be well under that. But in this scenario, that's kind of viewing where our thing has kind of failed. Okay, so yield strength is 2,901 psi, and ultimate strength is 4,293 psi. So we got to keep those in mind. Those are the properties for ABS plastic. Okay, so click this arrow here and then go down to simulation. Okay, so then I'm going to create study. Okay, and I am in no way a massive expert in this, but I've messed around with it enough to at least get an idea. We want to constrain it. We want to fix it on the bottom here. Okay, so this is like making it that cantilever, right? You want to go up to here and apply context. That's fine. 0.1 millimeters is fine. Okay. So it's setting that up. And then we want to go units, edit, and I want to make it inches because we have PSI, and it's just what we've been dealing with, okay? So now everything's in inches, and it's going to be in PSI. We got to add the load, okay? And we're just doing, once again, this isn't exactly how wind goes, obviously, but we're just going to add point load here, and I'm going to make it -5. There, newtons, okay? Sure, we're still, yeah, okay. I wanted it in, there we go, sorry, US inches. I didn't change it. So US inches. So that's embarrassing, but I didn't change it last time. Okay, so now we have this load. Okay, double click it if you want to edit it. It's just -1 pound, so it's going to make it -20 pounds. I'm going to make it pretty big. Okay, so this is a -20 pound load that's applied to here. The bottom is fixed. We add the context, and then you just hit solve. It takes some time to solve. Okay, it runs it on the cloud, and it's going to give us a bunch. We don't need a lot of the results. We just want to see a little bit of it. And the more complicated you design, the slower this takes. And a lot of students run into issues with Fusion, even on the senior computer yogas, when their designs get very complicated and the actual simulation takes a while to run. Okay, if we hit close, right now we're just in safety factor. I click here and change it to stress. Okay, so our max stress is 692.2, which is well under the 2,901 psi. Okay, it's down here. Okay, you can see once again, the farther we are away from the load, the higher the stress is. So that's because the moment's larger. Okay, 0 here because that's right, the moment's 0. Okay, tension here, compression here, same magnitude though. And then in the middle, it is 0. Okay, and kind of reiterating the things we talked about before. Okay, and then you could come up here and hit animate and actually hit play, and you can see as the load increases, the stress increases, and you can see the deflection. You can also look at displacement. Okay, hit play, watch as it goes. Okay, obviously it's the opposite where it's higher displacement here, and then you can look at strain, which is going to be very similar to the stress. Okay, because they're obviously related because we're under yield especially, and so it's a linear relationship. Okay, now let's think about it. So there's a bunch of variables we could change in all of this, and I want you guys, and then part of the assignment, to be going through the process of changing one variable and see how it behaves. Changing another variable, see how it behaves. So one thing you could change obviously is the load, like how much can this thing handle. So we go to -30. Okay, solve study. Okay, once again, if we're under 2,901 psi at our max, that means our structure is okay. Okay, so once again, this takes some time. Okay, but once again, it's kind of cool what it gives us, so it's definitely worth waiting for. Okay, almost there. Close. Okay, we still got strain. Okay, let's go to stress, and we're almost a third still, so we're just over 1,000. Once again, 2,900 is the max for yield. 4,293 is where it breaks. Okay, so we're still good. Okay, so let's change some other things. So finish results, simulation, go back to design. Okay, let's go to modify. We could change parameters. So the two big things we could change is the thickness. So you can make it 0.1. Okay, so that's reducing material cost, right? Okay, so make this 0.1. Okay, and then we go back to let's save it. These are saved. Go back to simulation. Okay, and then solve it. Okay, and so this is good. What did we just decrease? We just decreased the moment of inertia. Okay, by what I think is going to be a good amount. So that's going to affect the stress. Okay, because the larger the moment of inertia is, the less stress we're going to have, which in turn affects the strain, deflection, etc. Okay. So okay, and we're still good. Look at that. Okay, we're still at 1731. Now it's acting a little different up here because of the actual load. Underneath the load is experiencing a little different type of stress. That's not from the bending stress. Okay, but yeah, okay, so we're still good with that. So we could even increase the height. We go back and increase the height, or we could reduce the thickness a little more. Okay, that's the end of this first video. The next video, I'm going to actually add windows with parameters. Okay, because this is a pretty crappy skyscraper. Don't you agree? Can't really see out of it. Okay, so I'm going to add windows and kind of go through that process that Fazil Khan went through, that make the windows a little more, and see how it affects it. Okay, so finish results. Okay, it's already saved. Go back to design now, and then I'm going to end the video.